Hi friends, today we are going to solve the problem of minimum swaps 2 from interview preparation kit of the array section. So the problem statement given here is, you are given an unordered array consisting of consecutive integers 1, 2, 3 to n without any duplicates. You are allowed to swap any two element. Find the minimum number of swap required to sort the array in ascending order. So this is basically a medium difficulty level problem, so it's not an easy problem. So if you're thinking about sorting it using brute force method like a bubble sort, insertion sort, none of them would work because all of them has a complexity of n square. So in here we have to solve the problem with a complexity of big O of n rather than big O of n square. So this is the basic thing to understand. You might wonder then, if you are able to sort an array in big O of n, why do you use insertion sort or some other sort? So basically here, if you look at the problem statement states that all of them have a consecutive numbers. So this is a very important thing. So generally in other sorting methods which are able to sort them which will have number, basically in real life situation, the numbers does not is not a consecutive number to, and here all the numbers given here are a consecutive number, and also there are no duplicates. So this, because of these two things, you would be able to sort this array in big O of n. Once we have done that, we will basically look at these the input type. First it will give total number of the length of that array and then the elements in that array. I'm just looking for the complexity. Yeah, this is the complexity. So here if you look at the constraints, so basic constraint is 10 to the power 5, which is a huge number. And also if you're trying to solve it with big O of n, automatically the constraint would become 10 to the power of 10, which is a huge number and which is basically not feasible. So it will give you a runtime error. Let's solve it. Okay, first thing to look at in this problem is that what's the basic way. So first we will initialize a variable swaps equal to 0 because initially there are no swaps been made, and then something interesting which would be, we'll be creating another list with values of 0, and the length of that list would be similar to the length of the array, and all of those values would be 0 at first. Once we have done that, we would be looking, we would be enumerate in this index dot val to take our temporary list -1. So you might thinking what this thing is doing. So basically we are enumerating this array. So in for loop, in for each loop, what happens is, if you look at this array, so the each values would be 7, then after that would be 1, then 3. So the values means it is printing the every values in that array. Here what is doing this, we are also going to print the index of it. Okay, so here the index would be starting from, I guess, so here the index is starting from 0, so it will have an index of 0, 7. The second value would be 1, 1. The third value would be 2, 3, and it would go in this manner. And also if you look at this, the values in which index we are storing that. So it would be basically 7 minus 1. So we would be storing the 0th value at 7 at 6 position, because if you look at this array, so in Python the array indexing starts from 0. So if you look at the 7th position, which is the highest position, so for example in this area it will be the 7th position if you're counting it from 1, but here it would be 7 minus 1 equal to 6, so which is the value. So that's why we are doing in this way. Once the enumerator function has been done, would be looping in the array. So this is the basic problem. First we are checking if the array value is basically equal to the index value or not. So for example, for the 7th position, here the index value is I plus 1, so it basically the first index value is 0, so 0 plus 1 is 1, so ARR of 0 is 7. So you'd be checking it if it's an equal so in this case it is not equal to, so in that case we will go inside that if loop, and once we have been inside the if loop we would perform some functions and we will increment the swap value by 1. Here the total number of list value is quite large, so I've taken another list. If you look at this case, I've taken this picture from internet, so maybe it will help us to solve this code. So if you look at this, so initial values of ARR and temp is 4, 3, 1 and 2, and for temp is 2, 3, 1 and 0. So when you're enumerating as this value, so using the first, this code would generate this code would generate the temp value for this array. It will generate the temp value of 2310 for the array of 4, 3, 1 and 2. So this is the basic idea. So first, as you could see in our code, let's just, yeah, this looks good. Okay, so suppose our array is 4, 3, 1 and 2, and our temp value after running the enumerate function has been 2310. So at the first case, we are basically checking is if ARR of 0 is equal to if it's not equal to I plus 1, which is 4 not equal to 1, then you'll be going inside that loop. So the first value in that loop is t. So t equal to temp of 0 is basically, if you look at that temp list, temp of 0 is 2. Once you have get that temp value, we would be interchanging the values of the array. So basically we would be interchanging, if you then the second part is ARR of I comma ARR of t. So in array of I, we would be swapping that value with I plus 1. So basically the correct positional value that should be present in array of I, you are putting that value, and in the area of array of T, we would be swapping that value with the current value of array I. Once we have done that, we would be performing the similar swapping operation in our temp variable, in our not variable, in our temp list. So in our temp list, in the place of array of, sorry, in the temp list, in the place of temp of I, would be swapping that value with ith value, and inside temp of array t minus 1, we'll be swapping that value with t, and after that you'll be increasing this swap by 1. So as you could see here, the loop is only going just one time, means if it's iterating, there is just one loop. So the total complexity of this program is basically 1, so basically big O of n. So that's why this code is quite faster. Let's run the code. The code is done, and let's submit the code. As you could see, it passed all the test cases, and the best thing about this code is that, means I've seen more solutions in internet, but many of those are quite complex and quite difficult to understand. This code is quite compact, just few lines of code. So that's why I'm trying to figure it out, the best possible ways of solving a given problem. So this is the basic criteria, and if you please send me your feedbacks, and if you're able to find if you're able to find even better approach than this to solve this problem, please send me your comments, send me your feedback, send me the problem, send me the solution by which you have solved this current problem in an even better way. And as always, I keep on saying, please keep on watching this video and stay tuned, and have a nice day.